Right. I'm going to take you through interest calculations. So we've got two types of interest calculations. The first one is simple interest, and the other one is compound interest. Now let's quickly look at the difference between the two. So we are going to have here interest calculations, right? Interest calculations, and like I said, they are split into two. We have got simple interest and we've got compound interest. Now I'm going to start with the first one, which is simple interest. Now, simple interest, the name says it all. It's simple. Okay, so quickly, let's get to simple interest. What exactly is it all about? So the main thing you need to understand with simple interest is not added to the capital, right? But it accumulates separately, and there's no interest on interest. Okay, so what am I saying? Let's say you invest 1,000. Let's say you invest 1,000, right? In an account, you invest 1,000 in an account earning interest at, let's say, 10% per annum, simple interest. And then the question now says, A, calculate the interest and after 3 years, right? And then B, how much will be in the account, at the end of year 3. So let's look at this question whereby you invest 1,000, right, in an account earning interest at 10% per annum, simple interest. So there are some terms that I want you to know as far as simple interest is concerned. So there's simple interest. There you go. So we've got A, we've got I, which I call the big I. We've got S, we've got M, we've got N, and then we've got a small I. Now, before you start to look at questions on simple interest, I suggest you sit down for a day or two, an hour or two per day. Look at these 5 elements. Know them very well. Know how they smile, know how they dress, so that when you see them in the corridors or outside, you can be able to identify them. Because it's very important to be able to pick them out from a question. Because remember, every question, they will give you some of these elements. So if you know how they dress, you know how they smile, you know how they speak, you know their tone, their accent, you know what I mean, then life will be easy. So be friends with these guys, hang around them for some time and know them very well. So what am I saying? Someone might be confused. Hey, can I speak to A? Of course you can. Okay, so let's say A. What is A? So A is the amount invested, right? Amount invested. Some they call it the principal amount. Principal amount. Some they call it initial amount. You see, so all those terms you must be familiar with them. Those are the different suits that A can wear, either a black suit or a brown suit or a white suit. You see, so when you see a guy with a white suit, you know that, okay, most likely that should be A. Okay, so let's look at I. So I, the big I, is simply the interest end. This one is straightforward. Interest end. I always wears the same, the same clothes. The accent does not change. So yeah, and then S will be, of course, the total of these two, which is your, sometimes they call it accumulated amount. Some they call it future value. Some they call it final amount. All those terms, again, you must be familiar. Now let's look at N. N will be number of periods, number of interest periods, right? But normally you see that most questions they use N as years, but I don't want to say number of years, because let's say you are given a monthly rate and interest is worked every month, so you'll be confused. So let's just say N, the small n, is the number of periods. But just remember that most questions we are going to be using our N as the number of years if we are dealing with simple interest. Remember, N changes depending on which topic you are dealing with. So for simple interest, let's say N is the number of periods. Now your I is your interest rate. Your I is your interest rate. Now that we now know these guys, we know where they hang out, we know how they dress, we know how they speak. Now let's quickly come back to our question here. You invest 1,000, so immediately you see this. You know, okay, this should be A, right? So this should be A, which is the amount invested. So you indicate there, that's your A. Right, in an account earning interest at 10% per annum. So of course this should be your small I, simple interest, right? So we need one more element. So calculate the interest earned after 3 years. Now check this end part now. This is 10% per annum, simple interest. So it means our interest is worked out every year. Yes, our interest is worked out every year. Now for 3 years, so 3 will be your N, number of periods. So it's per year for 3 years. So your N, your small n will be 3. Now quickly, let's see how would we do that before we move on to the formulas. Let's see how do we do that. Now if I am to draw my timeline, it will look something like this. So I will have my 0 there, I will have my 1, I will have my 2 and my 3. Please, I want you to be familiar with drawing a timeline, because it is very, very important that you learn how to draw one. So what we are saying is, at this point you invested 1,000, right? So let's see, the bank at the end of year 1, they are going to calculate interest. But how are they going to do that? They are going to say 1,000, right, multiplied by 0.1, which is the 10%, and your answer is 100 rands. So 100 rands is added to your account. Okay, now at the end of year 2 again, the same thing will happen. They will again say 1000 multiplied by 0.1, and again the answer is 100. Right, so there you go. Again at the end of year 3, same thing, 1000 multiplied by 0.1, and the answer is 100. Now I want you to notice something. Interest is always calculated on the original amount invested. In other words, let's look at this part here. We are not working interest on 1.1. That's the amount invested plus the interest. We are working our interest on the same 1000 every year. So this is simple interest, whereby interest is not added to the capital, or you don't earn interest on interest. Right? So we are not compounding. It's simple interest. Now let's quickly answer the first question that was saying calculate the interest earned. So you earned 100 rands, 100 plus 100, so that is equals to 300. Right? So now let's quickly look at how we got this. So this is 1000 times 0.1 plus 1000 times 0.1, right? And then again here plus 1000 times 0.1. Now remember, this is your A, this is your I, plus this is your A, again this is your I, plus again this is your A, this is your I. Now this gives you 3AI. Remember, if we are doing maths, x plus x is 2x, right? So since it's AI, your answer is 3AI. But now remember, earlier on I said, since it's per annum and you've got 3 years, 3 per annums, that means your n is 3. So instead of saying 3 here, we rather say n. Right? But normally, just to make it presentable, we can rewrite our formula as interest, which is the simple interest, is equals to A times I times n. So there you go. There is your formula for simple interest. A times I times n. Now let's look at number B. Let's quickly look at number B, which says calculate the accumulated amount at the end of year 3. There you go. At the end of year 3. Now we know that I invested 1000, then I received interest of how much? Of 300 rands. Now if I add them together, I get 1300. But now let's see if I give names to these figures. The 1000 is called A, plus the 300 is A I N, which is, there you go. Right? Now if we go back to the maths that we did at grade R, yes, you heard me right, grade R, right? We factor out A, right? And then A into A is 1. Then A into AIN is IN. There you go. So it means our future value of 1.3, remember this is the same as your S. So your future value, this is your A, right? This is your A and this is your I. So our future value of 1.3 is equals to A plus AIN, principal amount plus interest. Mathematically, this can be rewritten in this form, A into 1 plus IN. So this is equals to S, formula number 2. So, for simple interest, this is everything. All you need to do is master the basics. Now, quickly, let me give a other question now here, quickly. We invest 100 rands in an account, earning interest at let's say 5% per month, right? 5% per month. Then I say now how much will be in the account, at the end, of month, at the end of let me say at the end of year 2, Now we can now see now that our question has changed. Before it was 10% per annum, now it's 5% per month. So it means we are earning, remember, don't forget, we are earning simple interest. Okay, so how do we do this? Let me just squeeze the answer here. So we are going to say, remember, how much is very important to know what you are looking for. You can imagine going to Pick and Pay and you want to buy cooking oil, but remember there are many brands of cooking oil. So if you don't know the brand that you use, you probably spend hours and hours just staring at those different brands. Olive oil is attractive, but it's very expensive. Sunflower oil is cheap, but it's not that attractive. So you see, you need to know what you want before you get into a supermarket. So how much will be in the account? So we need to know what we're looking for. So of course we are looking for S, as in the accumulated amount. So we know that our S is equals to the A into 1 plus IN, right? So now the A is the amount that you invested, that's the 100 rands, okay, into 1 is obviously 1, plus your I is 0.05. Remember, if you use the formula, always make it a decimal, simplify it, right? Then now, take note now, your N is no longer 2 years now, like before. Remember, before our N was 3, but why? Is because the interest was also per annum. Now, the N now is no longer 2, but the N now is 24. Why 24? Because interest is 5% per month. So how many months are there in 2 years? Is 24. So obviously this is going to be times 24. You see, so I want you to take note of this, the 24 and the 3 that we used in the previous question. Where is my 3? That 3 there. I want you to notice the difference between that, because it was per annum and 3 years. This is now per month for 2 years, per month for 2 years. So how many months are there in 2 years? Is 24. So this now gives you 100, open bracket, 1 plus 0.05 multiplied by 24, made a mistake again, 0.05 times 24, then close the bracket, then you get 220. There you go. So it means we are going to have 220. There you go. Simple interest. So, like I said at the beginning, it is indeed simple. Just like that. Now, one thing I also need to remind you is, remember, now that we know the master formula, which is the A is equals to I, let's look at these three formulas. Right, let's look at these three formulas. Now, if you are given the master formula, you can always find a third element. Now I can see that it's not that clear, so let me write it down here. So remember, we start with the master formula, and the master formula is interest, right, is equals to A, I, and N. So of course, you know from grade R maths, you can make either A, you can make I, or N the subject of the formula. Let's quickly do that. If I want to make A, I divide both sides by IN. I divide both sides by IN. So obviously the IN will cancel with the IN. Then it means A is equals to the big I divided by IN. Formula again. But remember, you don't need to waste time to understand this. Just know how to get it given the original one. Again, if I've got I is equals to AIN, and I want to remain with the small I, so I divide by AN, I divide by AN. So AN will cancel with AN, then I remain with the small I. So therefore, I is equals to the big I divided by AN. But of course, remember, the answer that you are going to get here is going to be a decimal. So you must multiply it by 100%. Yes. So this is the second one. And then the last one, again, I is equals to AIN, right? And then what then? And then we want to make N the subject of the formula, so we divide both sides by AI, divide both sides by AI. The AI will cancel with the AI, therefore N is equals to the big I divided by divided by A times the small I. Again, another formula. So you see, depending on the question, it's more like this. Sometimes, let's say you go to a baking school, right? You are doing a course in baking. Sometimes you can be given ingredients, you're given a recipe, then they ask you to bake a cheesecake, right? Which is okay. So, but sometimes now they can say, okay, close your mouth, guys. Then you close your mouth. Sorry, not your mouth. Of course, you can't eat with your mouth closed. Close your eyes. Yes, close your eyes. Then they give you 3 different pieces of, or should I say 3 different cakes, like 1 slice from a cheesecake, 1 slice from a chocolate cake, and 1 slice from any other type of a cake. So then they ask you, tell me, can you please tell me the cakes that you ate from number 1 to number 3? So of course, if you know how to bake a cheesecake, And of course, you know how it tests. It means you can easily identify it, right? So if you can identify it, then it's easy. Because let's say I ask you, what cake did you eat? And tell me what ingredients were used. Of course, the first question is you need to know the cake first. That, okay, is a cheesecake. Then if you know how to make a cheesecake from scratch, then you can tell me the ingredients that were used. So it's the same thing here. If you know how to do things from scratch, right, you can easily find the ingredients used. So let's pick one question just to illustrate how do we use this, because sometimes it's easier when we're just saying it now. I'm trying to look for a question here that we can use. Okay, so let's look at this question. It's on page okay, it's not clear, but it's on page 16 of our business calculations notes. So I'll just pick one. I'll just pick one question. I'll just pick one question. Okay, so let's look at this one. A money lender. Okay, it's not that clear again. I might need to write it down. So a money lender lent 1,250 on 16 January, and in settlement received 1,350 on 18 September of the same year, right? What annual rate of simple interest did he charge? So the question is, what annual rate of simple interest did he charge? Okay, so quickly we want to look at this question and see how exactly are we going to calculate this? How exactly are we going to calculate this question? So let's look at the first part first, which says what? A money lender gave money of 1,250 when? On 16 January. So quickly, I'm going to give you a few seconds to look at this and see. Just quickly look at the question. A money lender lent 1,250 on 16 January and in settlement received 1,350 on 18 September of the same year. And in settlement received 1,350 on 18 September of the same year. What annual rate of simple interest did he charge? Now you see, again, you get into a supermarket, you need to know. So you need to know what you are looking for, right? So now, quickly, let's see, what do we have? A money lender lent 1,250. Again, you need to give a name to this figure. What do we call this? So obviously, it is the amount at the beginning, or the principal amount, or the initial amount, whatever you want to call it. So obviously, this is our A. And in settlement, received 1,350. Obviously, this is our S. Immediately you see this, you remember that, okay, the difference between my A and my S is my big I. So without being told, you can now easily calculate that, okay, interest, which is the big I, is equals to S minus A. right? So my S is 1,350, my A is 1,250, right? Now, if I subtract the two, what do I get? If I subtract the two, what do I get? 1,350 minus 1,250, I think I get 100 rands, right? Yes. So we know that my interest is 100, but we also know that interest is equals to AIN. But now let's see. The question is asking us to calculate the interest rate, right? What annual? Again, annual, right? So quickly, let's see here. Now there is a slight problem. Your N is not as simple as 2 or 3 or 4, but it is in days. Do you see that? Now quickly, let's see. In January, how many days do we have? In January, how many days do we have? So here we want to calculate the number of days. So in January, we have got 31 days. But we are now going to say 31 minus 16, which gives you 15 days in January. What about Feb? Feb has got 28 days, right? What about March? March has got 31. April, 30. May, 31. June, 30. July, 31. And then August, August also has got 31, right? And then September now, we don't count the whole month. Why? Because it's on the 18th. So it will be 18 there. So quickly, let's add our days and see what do we get. Right, you see, so if I add all my days, I'm getting 245 days. 245 days. So this is my N. But now remember, now since it's days, then we need to make this over 365, since we're looking for an annual rate, right? So we are now going to say my I, which is the 100 rands, is equals to 100, is equals to the A, which is the 1,250 multiplied by, right, the I, which I don't know, times the N, which is 245 divided by 365. There you go. And then you solve for I. But if you want again, don't start here. Go straight to your formula for I, which is there. I is equals to I, the big I, over AN. Same thing. So I is equals to the big I, which is 100 rands, divided by A, 1,250, multiplied by 245, divided by 365. There you go. Now you need to be very careful when you punch this part here. It's either you are going to change it and say 1250 times 245 multiplied by 365. But I mean, you can choose whichever way. So I'm going to say 100 divided by, then I open bracket, because my denominator here is with more than one number, 1,250 multiplied by 245, right? Divided by 365. Then I close the bracket. So this is my denominator there. Then I get my answer as 0. But remember, I said your answer here would be obviously a decimal. So we must multiply it by 100. Multiply by 100. What do you get? 11.91. So your answer here is 11.9. Actually, it's 92. Yes, 92. 11.92% per annum. So you see, let's now quickly go through for the last time through the question. A money lender lent 1250. So of course you know that this is A on 16 January. Okay, fine. And in settlement received one. So again, this is S. Immediately you see this in your mind, you need now to come up with this. Right, the I is goes to S minus A, which is 100 trends. Okay, fine. What annual rate of simple interest did he charge? Now, if we look for the ingredients that we have, you only need 3 to get the fourth one. Now we've got 2, so of course we need to find our N, which is the period. Now, since they are saying what annual rate, that means your period must be in years. But now you see, from January 16 to September 18, there are 245 days. But now, how do you convert days to years? You divide by 365, yes, because in 1 year there are 365 days. So there you go. So this is the same as years. This one, we have converted days to years. So once you do this, you go there. But remember, like I said, you must know how to punch this part here. Very important. So your answer is 11.92. Simple interest. Right. Now that we have done simple interest, let's quickly move on to the second part, which is bills of exchange. Right, which is bills of exchange. Right, so I'm going to take you through the steps that are involved in this for you to have a good understanding of this section. So basically, a bill of exchange is more like a promissory note, which is just a signed document, right, where one party promises to pay a certain amount at a specified date or on demand. But the ones that we are working with in our syllabus, it will be when you are required to pay a specific amount on a specific date. So I'll give a very simple example. But before let me give you an example first, then I will quickly show you something. So let's say I bought goods on the 1st of January, right? This is 2016. So I bought goods on credit, right? And I bought them from, let's say, ABC Traders. ABC Traders, okay? And these goods are for, let's say, 4,000, right? And obviously it is addressed to me, which is Masama. There you go. And there is going to be the terms, right? So this is 4,000 rands, of course, not dollars. And there are going to be terms, right? E.g., the terms can be 3M D. It can be 3M S. It can be 30 or 40 or 50 or 10. But I will just use 30 for my example. 30 DD. It can be 30 DS. Now, not all these terms will be on one bill. Only one will be there. So let's say on our bill there is 30 DD, right? Which is simply means the bill or the amount of 4,000 is due 30 days from the date the bill is drawn. Now, quickly, let me show you. I googled there an image of a bill of exchange. Now, if you can see here, you can see there on top there is a 4,000, which is the same as my 4,000 there, and then there is the address, the date when the bill was actually drawn, right? And of course, the company or the business that must receive the money, and of course to whom the bill is addressed to. Now let's look at the terms. Is 3 months after date, right? 3 months after date. Which date? Of course, there, right? So 3 months after date, pay to us or our order. Now I want you to get this part here, or our order. So 3 months after the date, pay to us or our order the sum of rupees 4,000 only for value received, right? Okay, so that is more like a bill, same thing as one I have here, but of course mine is simple. Even the one I showed you also is simple, but yeah. So this is a bill of exchange. That's a bill of exchange. And then, so I'm going to buy goods for 4,000, or maybe I must pay someone money, but I don't have money, so they draw a bill. Fine. But anyway, the fact is I owe someone money, 4,000, and I must pay it 30 days from the date the bill is drawn. Now, so let's quickly go back. Remember I said please know how to draw a timeline. It is very easy. It always starts with a straight line. So there is your date drawn. In our case, our bill is drawn when? On the 1st of January. So 1st of January 2016. Okay. And then when is the bill due? Now the bill is due 30 days from the date it is drawn. Now 1 January plus 30 obviously gives us 31 January. Right, 31 January 2016. Okay. Now, let's see now. So I'm going to get a copy. Obviously, the shop or whoever I must pay the money to will also remain with a copy. I get a copy, then I go. Now, 10 days down the line, on the 11th, right? So let's say here, on the 11th of January, these guys or this shop, they need money. But remember, we signed a contract. For those who did law, you know that sometimes it's not that easy to just breach the contract, right? And sometimes it's even impossible to breach the contract. So we have signed an agreement, and it says I must pay the money when? On the 31st. But they need money on the 11th. It's urgent. They need money. So what do? You see, when I showed you that example, then it says pay us or our order, right? So order means no, don't pay us anymore, but pay this person. That's the same as that. So okay, let's come back to our scenario. On the 11th, these guys, they need money, right? So these guys, they need money on the 11th, but they can't call me now because I only pay them on the 31st of January. So what they are going to do is they are going to sell the bill. They are going to discount the bill. They are going to discount the bill, which is they are going to exchange the bill, which is this paper, for money. So they will go to financial institutions, right, that do discount bills, and let's see now the process. What does this process entail? So there we go. Right. So let's say they go to this institution, A, B, D, financial institution. Financial institution. Okay. And then they tell them that our discounting rate, or the rate that we are going to discount this bill, is 10% per annum. Now let's see. We want to know how much is this guy going to get on the 11th? So we need to calculate how many days are there between 11 and 31. How many days were these guys going to wait? If they had to wait up to 31, how many days should they wait until they get their money? So we call that period T, which is referred to as the unexpired period. Unexpired period. Okay, so now we need to know our T, which is the unexpired period. So 11 days have already expired because we are now on the 11th. So 11 days have already expired. So 31 minus 11 gives you 20. So it means our T in this case is 20 days. The unexpired period is 20. So what these guys, this institution, they are going to say, okay, what is the value that is on your bill? And that value, what we call it, this value here, the 4,000, is called the face value, not FVR, not future value, sorry, but it is the face value. It is the face value of the bill. So they are going to ask, they are going to take the face value of the bill, which is 4,000. So they write there 4,000. Then they're going to multiply by their discounting rate, which is 10%. But remember, this is 10% per annum. And our T is not even a month. Our T is only 20 days. So they must adjust it accordingly, times 20 over 365. So now, quickly, let's do that. 4,000, right, multiplied by 0.1, multiplied by 20, divided by 365. And then you get 21,917. No, sorry. You get 21. I'm too generous. You get 21,92. So these guys will say, okay, this amount here that we calculated here, right? This is the discount that we are going to charge you. It's more like the interest, right? It's more like interest. So this is now called the banker's discount. Banker's discount. So remember this. We have now done what is T. We've done the face value. Now we've just done now the banker's discount. So how much are these guys going to get? So they will get 4,000 minus the banker's discount of 21.92, which gives you, so 4,000 minus 21.92 gives you 3,000. Sorry, my space now. Okay, I have to just put it, extend down there, which is 3,978,08. There you go. And what do we call this amount? Of course, this is the money that they are receiving. So it's called the cash value. So quickly, let's list down all the terms that we have from the beginning. We've got the face value when the bill is drawn. Then we've got the discounting date, of course. Then we've got T, which is the unexpired period, when the difference between the date of discounting and the due date. That's our T. Then we also have R, which is this one, the discounting rate. This one is called the discounting rate. Discounting rate, right, which is R, right? And we also have the BD, which I just worked out there, the banker's discount. And finally, we've got the CV, which I just got there, the cash value. Now, this is bills in general, right? That's bills for you in general. So quickly, let's now come up with formulas. So firstly, remember I said we have got our bill, which is this one. Then on the 11th, you're going to discount it. So the first thing is the bank or the financial institution is going to calculate the discount. How do they get it? So banker's discount is equals to, let's see, how did we get ours? 4,000, which we say the 4,000 is the FV, right? They multiply that by the rate, which is our R, right? And then we multiply by the unexpired period, which is our T. So this is a formula for banker's discount, right? And once you get the banker's discount, you are now going to say the face value, which we got there, minus the banker's discount, which we also got there. This gives you the cash value, which you get there. Right? Remember, this formula here, even there again, you can make anything the subject of the formula. You can make FV subject of formula, you can make R, you can make T, just like the same way I explained under simple interest. So I'm not going to waste time going there, but I just want you to remember that here, let's say you are given FV and CV, you can always get your BD. So basically, this is everything on bills. So a bill is drawn, right, on when? On the 1st of January, there is our date drawn. But now, 10 days later, that is on the 11th, the guys need money. But now this is just a paper. It's just a promissory note that you get money on the 31st. A note does not bring cash. So they have to go to a financial institution, right, to discount the bill, which is simply to exchange it for cash before its due date. So now they went to the institution called ABD, right, and their discounting rate there is 10% per annum. So they work their BD as 4,000 times 10 times 20 over 365. Where's the 20 coming from? 20 is the T, the unexpired period, which is simply 31 days minus 11 days. Then once they get the BD, they now say 4,000 minus 2 on that, and then they get 3978.08, which is called the cash value. Now, formulas, BD is equals to FV times R times T. BD is equals to FV times R times T. Then CV is equals to FV minus BD, which is again this 4,000 minus 2192. So, it is very important that before you answer any question, sit down with this page, right? Go through it again. Don't forget your bill. There is a bill there, right? So sit down with this, look at your bill, right? Know these terms again. So this means the bill is due 3 months from the date it is drawn. 3 months from the date it is seen. This is when the bill was posted, right? Let's say via mail or whatever. And again, 30 days from the date the bill is seen. Remember, I just used 3, just an example, but I'm not saying all the bills will be 3, right? And again, the same applies to the 30 days. It's not all the bills are. I just used it as an example. Now, it's very important. Know this. You know it very well. Now, let's see, how do we use this to answer questions? So I'm going to write down this question since you can't see clearly. So there is a bill for 2,190 accepted at 90 D is discounted on July 18, for 2,170.80 cents at the bank. Then calculate number 1, the due date, and number 2, the date of acceptance. Date of acceptance. If the discount rate is 8%, 8% per annum. There we go. Now, a bill for 2190 accepted at 90 DD is discounted on July 18th for 2170.80 at the bank. Calculate the due date, the date of acceptance, if the discount rate is 8% per annum. Now, again, just like I said under simple interest, please know your guys very well. So as you read the question, if you still understand there, remember in the previous scenario, our bill, this is our bill, and this is the face value. So let's see now, a bill for, immediately you know that, okay, this should be my face value. There you go. Right, so a bill for this much, so that's my face value. I accepted it, so these are your terms, means 90 days from the date the bill was drawn, is discounted on July 18th, so that's the discounting date at that. So that's your CV. Now, let's quickly draw a timeline. So there is the date, that's the date of acceptance or the date drawn. Right, date of acceptance or date drawn, same thing. Right, now, then we've got the due date there. Due date. We don't know these two dates, but what we know now is between them, right, between them there is 90 days. Okay, now the face value of this bill is 2,190. Now let's see, at some point, maybe here, any point between, which is the 18th of July, which is that date there, July the 18th. So the bill was discounted. So again, same approach. Bill was discounted, and the discounting rate we're given there as 8%. Now, we know very well that in the previous case, we were not given the CV. We had to work it out from the beginning up until the end. Now they gave us the CV. It means they've already calculated the BD. So from the two, you can conclude that your BD, that's your banker's discount, is equals to your FV minus your CV, which is the same formula as this one. FV minus BD is equals to CV. So if you take CV comes there, it becomes a minus. BD goes there, becomes a plus. So this is the same formula as this one. Now, your FV is 2,190 and your CV is 2,170.80. Now this gives you what? 19 rands and 20 cents. So this is your BD. Right. I think I'm going to need more space here. I'm going to need more space. But we also know that this period here between 18 up to the due date is called T, which is the unexpired period. Right? So if we can find T, we can find the due date. Because T links discounting date and due date. But how can we find T? How can we find T? Okay, I know of a formula that has got T. The formula says BD is equals to face value multiplied by the rate multiplied by T. So we are simply saying the 1920, which is a BD, is equals to the face value, which is 2,190, right, multiplied by 0.08 multiplied by T over 365. Now, very important is this part. Very important is this part. It's either for now you can just say T and remember to multiply by this at the end, but it's safe to always write T over 365 from the word go, right? Why? Because normally your T is in days. In most cases, it will be in days, right? So there you go, over 365. Now, let's simplify this. I'm going to multiply these two. Remember, this is the same as over 1, same as over 1, right? So I'm going to multiply the numerators, which is 2,190 multiplied by 0.08, and that gives us our answer there of 175.2, right? So this is 175.2. Of course, it's times T, so the T comes back. Then divided by 1 times that gives you 365, right? Then this is equals to 1920. As you know, again, is the same as over 1, right? It's just the same thing. Now I'm going to extend my box there because I need some more space. Okay, I need some more space there. Okay, so now from there we continue up there. We do what we call cross multiplication. We multiply this by that, right? So I'm going to so it will be 1920 multiplied by 365 is equals to 175.2 T. And what do? We divide both sides by 175, 175.2, 175.2. So let's go. 19.20 multiplied by 365 is equals to, divided by 175.2, that is 40 on the dot. So that's 40 days. So your T is 40 days. Now, if it's 40 days here, so let's add 18 July plus 40 days. Let's see where it takes that to. Now, in July, 18 days have already expired. So in July, if you say 31 days minus 18, that gives you 13 days. So in July, there are 13 days that are not yet expired, or there are 13 unexpired days, because 18, 1/8, you have already expired. July has got 31 days. So 31 minus 18 gives you 13. Now remember, we want 40. So from 13, we are short with 27. So it means the due date is 27 of August. So this is 27 August. There you go. 27 of August. Now, that's number 1. So the first part answered. The answer is 27 of August. Now let's look at the date of acceptance. So you simply count 90 days from this going back. Or the easy way, you see, we know that from here to there is 90. But from 19 July going onwards is 40. So of course from 18 July backwards it should be 50. Perfect. So there and there. So this is 50 days. Remember, we are counting 18 July there because we did not count 18 July there. Remember, we said 31 minus 18. It simply means when we went this side, we said 19, 20 up to 31. So when you go backwards, remember to count 18 in. So let's quickly do that. So July has got 18 days that have already expired. Remember, the 50 is the 50 days that have expired. Expired days plus unexpired days give me the total of 90. So in July, 18 days have already expired. Let's go back. So June, there are 30 days, right? And in June, so that's July, that's June, and obviously that's May. So May, of course, is 2 days that have already expired. Now, if you say 31 minus 2, that gives you what? So this is 50 days in total. So if you say May, 31 minus 2 gives you 29. So it means the bill was drawn on the 29th of May. The bill was drawn on the 29th of May. So this answer here is 29 of May. Remember, the days expired in May are 2. And when you say an expired day, it must be a full day. That means you don't count the day the bill was drawn. Because what if the bill was drawn at the end of business hours? Obviously, we can't count that day in. I'm not sure if you get what I'm saying. If you draw a bill on the 1st of January and you want to count 20 days, you start counting from 2 as 1, 3, 2, and. So the same thing applies here. In May, there are 2 expired days, right? So that means your date drawn is 29. Because if you now say 31 minus 29, it now gives you 2 days in May. So it's 48 here, but we want to get to 50, so you add 2. That means the date drawn is 29. So if this was 3, it would be 31 minus 3, which is 28. Okay, so this is it. That's bills. But now let me give you another version. What if this part, what if it was 3MD, 3 months from the date the bill is drawn? Now, once you get your due date here of 27 August, unfortunately, you can't do it this way, whereby we came here and we count backwards. You can't. Why? Because now, from this part now to that part now, if I'm using 3MD, it means this part here is going to be 3 months. See now, if I use this, it will be 3 months, right? But my due date is August 27. So how do you get the date drawn if your terms are in months? So you simply say, okay, August, I have to go 3 months back. So if I go back to July, that's 1 month. If I go back to June, that's 2 months. If I go back to May, that's 3 months. Then for the date, you just copy the same date that is here, which is 27 May. So if the terms were 3MD, you would count 3 months back, which is 27 May. And it's easy. You just come to this month, which is 27 there. For now, let's look at the month only. Let's go. July, that's 1. June, that's 2. May, that's 3. For the date, just copy this date and put it there. Then done. So this is bills. And I've just done one example, but I think it explains everything. So please get as many questions as possible. See if you have understood this. If you haven't, come back again. Just look exactly where are you getting lost. And remember our foundation there. This you need to know first, right? You not to cram, you need to understand how bills operate. Remember, in my first session on interest calculations, when I did simple interest, I I mentioned that there are two types of interest calculations, which is simple interest and compound interest. Now, we have just done simple interest. Now, let's quickly look at compound interest. Now, compound interest. As usual, let's start with an example. Right, so let's say this is invest 1,000 at an interest rate of 10% per annum, compounded annually. Alright, then the question is, how much will be in the account? How much will be in the account at the end of year, let's say 3. Now, so quickly, let's look at this. As usual, we start with our timeline. So that's 0, that's 1, that's 2, and that's 3. So let's see. Compound interest. How much did you invest? You invested 1,000. Now, at the end of year 1, they are going to calculate interest as follows, as the same way that we are doing. Interest is equals to A times I times N, because it's only for one period, right? So, which is equals to the 1,000, which is the opening balance, multiplied by 0.1, which is that one, and of course multiplied by 1, because it's only for 1 year. Remember, it's per annum, and this is 1 year. Our timeline is in years, and obviously the answer gives you 100 rands. Now, what this means now is the balance in the account is now going to be 1,100. So take note of this now. The interest is now added, and the new balance is 1.1. Now, at the end of year 2, we are now going again to use the same formula, which is interest is equals to AIN. But the difference now is your interest, your A, is no longer the 1,000 like under simple interest, but the 1.1 now becomes your A. So this is equals to 1,100 multiplied by 0.1 multiplied by 1, because again it's only 1 year, and then your answer is 1,100. That should be 110 times 0.1. That's correct, 110. And again 110 plus 1.1, that gives you 1,000. So your balance at the end of year 2 is equals to 1,210, which is the closing balance. So you see, at this point it was only the capital. So the 1.1 is now capital plus interest. At this point now, so you see, the 1.1 is earning interest. That means the capital of 100 plus the interest, sorry, the capital of 1,000 plus the interest of 100, they're both earning interest. So what this means now is interest. There's interest on interest. We are compounding, adding up, adding up, adding up. So there's interest on interest. So interest does earn its own interest as time goes on. Basically, that's what compound interest is all about, right? So again, same process. At the end of year 3, we do the same thing. Interest is equals to AIN, and then our A now is now the beginning of year. Remember, one more thing. 1 means end of year 1, beginning of year 2. 2 means end of year 2, beginning of year 3. 3 means end of year 3, beginning of year 4. That's how you interpret your timeline. So there is equals to 1,210 multiplied by 0.1 multiplied by multiplied by 1, because it's for 1 year, and your answer is 121. So if I add there, I get now my balance is now 1,331. There you go. So you see, let's now look at these figures here. Remember, here we multiply that, there, and there. Okay, so basically what this means is, if I'm not going to go deeper into how we are going to derive a formula, but the formula is your S, which is the future value, is equals to your A into 1 plus I, which is the interest rate, divided by M, right, to the power of M times N. So let's look at our variables. Now remember, I said the N will differ from one topic to another. Now remember, our N for simple interest was number of periods. And although I said it can be years in most cases, but sometimes also it can be months. I did show you an example when it was months. But now for compound interest, N is strictly number of years. So N is strictly number of years. And the new guy now, the small m, or m because it's only one m, this is the number of compounds per year. Compounds per year. So of course, if it is 10% compounded annually, it means your m is 1. Again, same thing as this, compound per year. And of course, by now you know the I, of course, it is the interest rate. Interest rate. And of course, the A, you know, from simple interest, you now know that A is your amount invested, principal amount, and all those terms, all those different suits that A can wear. And of course, N, you know that it is a final value, accumulated sum, what. So this is a formula for compound interest, if you want to use a formula. So quickly, let's see. So your S is equals to 1,000, because that's your A, open bracket, 1 plus. Now your I is 0,1. Now, we could say divided by 1, but there's no need to. But anyway, if you want it to be exactly like this, it's okay. You are more than welcome. You divide there by 1, but there's no need to. So you close the bracket to the power of course, if this is 1, obviously this will be 1 times. But again, there's no need to put this. 1 times is for 3 years. 1 times 3. So there's no need to do all that. You can simply write your answer as to the power of 3. Right. Now, let's punch here. Let's calculate our answer. So now I'm going to show you now with two calculators, with Sharp and HP. Right, so we are going to say 1,000. We open bracket. There is the open bracket there. Then 1 plus 0.1. You close the bracket. There is the close bracket. Then to the power of 3. So there, if you see in orange there, there is a y to the power of x. On your dip pattern there, you see in orange there. So you say second function depreciation. You see that power there. Then you put your 3, then you get your answer, which is 1,331. Now, if you are using the HP calculator, right, I suggest you start with this part here, this part there. So you are going to open bracket, which is shift right, open bracket. So that's your open bracket there. Shift, you open bracket. Then you say 1 plus 0, 1. Now you see, take note, we could have ignored this bracket and said 1.1, right? But I'm just opening bracket so that at least when it's 0.1 divided by 12, then again you know what to do. But of course, someone might ask, why not just say 1.1? It is possible. It's possible also. But if it was 0.1 divided by 12, then it becomes tricky now because there are a lot of decimals. So 0.1, right, divide by 1, then you close your bracket. So you say now divide by 1, then again shift, you close the bracket, then you say to the power of 3, right, shift the 3 is equals to that 1 point something. Remember, I said shift, then to the power of, that's my power there, then 3. And I got that. Then of course I multiply it by the amount invested, which is 1,000. And what do I get? 1,331. There you go. So let's go again for the last time. Shift, open bracket, 1 plus 0.1 divided by 1, but there's no need to, just say 0.1. Shift, close bracket, then second function, power of 3, and then get your answer, multiply by 1,000, get your answer. But like I said, we could have simply said 1.1, right, second function to the power of 3, and then you get your answer, then you multiply by 1,000. Again, same thing. Okay, so basically that's how you use the formula to get a compound interest, or to get the accumulated amount at the end. And of course, if they ask you for the interest, you simply say the amount invested, right, subtracted from the amount received. So obviously the difference between the two becomes the interest earned. Now, you can also use the calculator, the financial calculator, to do the same thing. So let's see. Before we look at the calculator, let's look at the elements that we have in the calculator. We've got PV, we've got FV, we've got N, and we've got I. So let's look at these things for both calculators. So there is your N, there is your I, there is your PV, PMT, and your FV. Right? And of course with Sharp, remember everything we always say compute. So it's the top row there. Now let's look at HP again. Same thing. There's your N, there's your I, there's your PV, there's your PMT, and there's your FV. With HP, there's no need to press compute. You just go straight to what you're looking for. And before I continue, you must know how to clear the memory for your calculator. So for Sharp, it's second function, alpha, 0. You see, there, clear memory. You say 0. It's now cleared. Now for the HP, it's just shift, clear all. Shift, clear all. Now, let's quickly go. And another thing with especially with HP, I know Sharp, normally the default for Sharp is always 1 per year. Which is, if I say second function, my I, you see there, it's 1. So the default for Sharp is 1 per year, but sometimes, okay, mine here, I've already set it to 1 per year. So you see there it's 1 per year, but normally most HP, they come with 12 per year. So again, you need to make sure that you are using the correct compounding. Right? But for now, since it's compounded annually, then you must change it to 1 per year. So how do you change your compounds or your periods per year? You say 1, shift, then PMT. You see PMT in orange there is per year. So that's how you make it 1 per year. So let's say I want to change it to 12. So it's 12, right? Shift PMT is now 12 per year. Let's go back to 1. It's 1, shift PMT is now 1 per year. Good. So normally my students, I advise them to leave their calculator at 1 per year and not set it after every calculation, because it makes life easy. But however you decide if you want to set or not set is entirely up to you. Now let's come back here. Now you need to know these guys very well, just like under simple interest. Talk to them, invite them to lunch, sit down, know their tone, their accent, the kind of clothes they like to wear, all those things. Know everything about them. And even if you see them from the back, you can identify them. Have you ever seen someone far away from you, and the person is going in the same direction with you, so you only see the back, but because you now know that person in and out, you can tell that is John, even without looking at his face. So that's exactly what I am talking about here. So let's quickly check. Remember, PV is the same as your A. So if you know your A, you know your PV, principal amount, amount invested, what. Then your FV is of course your S, that's your accumulated amount, what. Now there is a problem. This is the problem. So this one, it is the number of compounds. Number of compounds. And remember, we are talking of total compounds. Total compounds, right? So, and also you remember that this is equals to M, the small m, times N. Remember the formula? This one. So these two, they are equal to the big N. So remember, compounds per year times number of years. Let's say it's compounded monthly for 10 years. So it will be 12 times 10, that's 120. So in your machine, you just put 120 there. So remember that the big N is equals to M times the small n. So this is a problem. This is a problem. So you need to spend more time with this guy, buy lunch, sit down, talk, chat. Yeah, then know him very well. Then you won't be disappointed. Now this one, that's easy. Obviously, that's your interest rate. Okay. So let's now see. Let's do the same question that we have. Invest 1,000 at 10% per annum, compounded annually. How much? So again, same thing. You need to know what you are given. So let's say you want to use the calculator. You need to give names to these figures. So the 1,000 is of course your present value. Your 10% is of course your I, right? That's your I, and your how much will be in the account at the end of year 3. Now 3 is not necessarily N. I don't want to say 3 is N. But let's see. Yes, N is 3, but not this 3. It's because interest is compounded annually, you see, and it's for 3 years. So 1 times 3 is 3. So our N, our big N, it is 3, but not because of this 3. It's a combination of compounded annually and 3 years, 3 annuals, right? 3 years annually. So there you go. Let's now put it in our calculator. So we're going to say 1,000 plus minus present value. Now, on the use of the plus minus, sometimes it doesn't really matter, but normally I prefer to use this when I'm taking money out of my pocket, then it's a plus minus. So you'll see some people, even if it's FV, they also use plus minus. But I mean, it all depends. It all depends, yes. So let's quickly look at this. N, which is the number of compounds. Remember we said it is 3, and your I, it is 10. Or 10 divided by 1. Remember, it's the same. The same thing that you put here, same thing that you put there. The only difference now is you don't put this as a decimal, you put it as 10, right? So I'm going to start with the HP. Of course I need to clear all, so I'm going to say 1000, then plus minus, that is my PV, then my 3 is my N, and then my 10 is my I. Now what am I looking for? I'm looking for the future value. There you go, you get your FV. So now you say compute future value, and the answer is 1331, right? And here same thing, 1000 plus minus, there's a plus minus there, plus minus, that is your PV, then 3 is your N, then 10 is your I, and compute first, then FV. Same answer, 1331. So that is how you calculate your future value using calculators. Now, another scenario, another example, which is slightly different from this one. Now I want to invest. I want to invest 1,000 at 10% per annum compounded monthly. Okay, so I'm going to do A, compounded monthly. I'm going to do B, compounded to monthly. Going to do C, compounded 3 monthly, which is the same again as quarterly. Then I'm going to do D, which is compounded 4 monthly, and then lastly I'm going to do E, which is compounded half yearly or 6 monthly, same thing. Half yearly. So quickly, let's look at this scenario, and the question is, how much will be in the account at the end of year 2? Now let's say 3 again. Say 3. Right. So we have got the same question. Invest 1,000 at 10% per annum, compounded monthly, compounded 2 monthly, compounded 3 monthly, compounded 4 monthly, compounded half yearly. How much will be in the account at the end of year 3? So again, we're looking for future value. So quickly, I'm going to draw my timeline, but I think first I'm going to split my page into A, B, C, D, and E. So there is my A, there is my B, there is my C, there is my D, and so A, B, C, D, E. Okay, perfect. So let's start with A here. Right. So A says what? It's at invest 1,000 at 10% per annum, compounded monthly. How much will be in the account at the end of year 3? So it's compounded monthly. So I know that my 1,000, of course, it is 1,000 plus minus present value. my n. Now remember, let's say we were using the formula. How were we going to do this? So it's compounded monthly. What is m? So m is number of compounds per year. Number of compounds per year. That means on each of these we have got a different value of m, 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 and a different value of m. Now if we compound monthly, right, if we compound monthly, we compound 2 monthly, we compound 3 monthly, again we compound 4 monthly, we compound 5 monthly, 6 monthly, 6 monthly. Good. So if we compound monthly, your m is 12, because remember m is number of compounds per year. 2 monthly, your m is 6. 3 monthly, your m is 4, because it's quarterly. 3, 6, 8, 9, 12. 4 monthly is 3. People, they always confuse these two. They are always confused. When you say 4 monthly, some people they think it's quarterly. When you say quarterly, some people they think it's 4 monthly. It's not the same. And of course, 6 monthly, your m is 2. So let's come here now. Let's come to number A. Number A now says what? Compounded monthly. So we know that our m already is 12. There it is. And it's for 3 years. So if you go back to the formula there for them, it's m times n, which is the 12 times the 3. So it means your n is going to be 36. In simple terms, we are saying there are 36 compounds in 3 years if I'm compounding monthly. Right? 36 compounds in 3 years if I'm compounding monthly. 36 monthly compounds in simple terms. Then of course your I. Now here now is slightly different. Whether you set your calculator or you don't set, both HP and Sharp can decide to set their calculators, but I prefer not to set mine. Right? I prefer not to set mine. So let's say you want to set Sharp. What do? So you go second function per year. You see there is already one there. So if you want to change it, let's say to like here is 12. So you are going to say 12. Then you say enter. So it's already changed now. So if you do that, you see now it's now 12. Now when you set your machine to 12, right, you are not going to divide your rate. But for me, I don't set my calculator. I always leave it at 1 per year. So it all depends. So 1 enter. So mine is always at 1 per year to make it easy. Right? Again, the same applies also with HP. My suggestion is you can leave it at 1 per year. Then we only play around with our rate. But at the end of the day, you decide. Right? You decide. So my I, I'm going to say 10 divided by 12. Why? Because remember, my calculator is set at 1 per year. Right? 1 period per year. 1 period per year. So what that simply means is the 10% is for the whole year. But since my period is 1 month, I must get the interest for also 1 month. Since my calculator is set at 1 per year, 1 period per year, right? So you might as well change your rate again to 10 divided by 12. But again, if you want, you can set your calculator to 12 per year. It's okay. Now, if your machine is set to 12 per year, then you don't have to do this now. You just say 10, because the machine is already set to 12 per year. I'm going to show you now quickly. So let's say you want to set. So you will say 12 shift per year. So it's now set now. Okay. So we say 1,000 plus minus, that's your PV. Then you say 36, that's your N, and you say 10, only 10, that's your I. Then you compute your FV. So let's see. The FV is 1,348. 1,000. Okay, so I've just shown you now how to get this answer after setting our calculator to 12 per year. Now let us remove the setting. Let's go back to 1 per year. Right, so we say 1,000 plus minus PV. Then we say 36, that's your N. Then now if you don't set your calculator, you simply say 10 divided by 12. Then that's your I. Then you compute your FV. You see, it will give you the same answer of 1,314.18. So you can choose to set your calculator or not to set. But I prefer not to set mine, because for some reason, if you forget to change your settings, then your answer becomes wrong. And unfortunately, there won't be anyone to tell you that, hey, listen, your answer is wrong. So just to be safe, I prefer not to set my calculator. Rather, I only play around with my interest. If it's compounded 2 monthly, let's see how do I put it. It will be 1,000, right, plus minus PV, and then your N, and then your I. So now again, remember N is number of compounds in total. So if it's 6 per year, so obviously your N is 6 multiplied by 3, because remember, back to our question again, we are investing it for 3 years. So if it's in 1 year there are 6 compounds, in 3 years there are 18 compounds. You see how easy to get N, but you need to spend enough time with N, know N very well, right? Then your I simply divide 10 divided by 6. Why? Because there are 6 periods in 1 year. So this is if I don't set my calculator. If I set my calculator, then I have to set it to 6 per year. First of all, let me get my answer without setting it. So is 1 per year. Okay, it's okay. So let's go 1,000 plus minus, that's my present value. Then 18 is my N, and then 10 divided by 6 is my I. Then I compute my FV. So my answer is 1,346,53. Right, so let's say I want to set my calculator. So first of all, I say 6, right, shift PMT is now set 6 per year. Then I say my rate is 10, that's my I. My 1,000 is my PV, and my 18, that's my N. Then I compute FV. You see, same answer, 1,346.53. So basically, you choose what you want to work with. So I'm going to continue all the way to the end, but now I won't show you again how to set, but I'll simply do it without setting the calculator. Right? So I'm going to leave it at 1 per year. So 1, go back to per year. There we go. So again, it's 1,000. Right, 1,000 plus minus PV, my N, then my I. Again, 1,000 plus minus PV, my N, and my I. And again, 1,000 plus minus PV, my N, and my I. And of course, I'm looking for FV, I'm looking for FV, I'm looking for FV. Now, depending on the method that you use, I want you to pause this this video for a while. Look at these figures, look at the question, right? We're now busy with C, this is A, this is B, this is C, this is D and E. So we are now busy with number C now, and number C says compounded 3 monthly, compounded 4 monthly, and compounded half yearly. So I want you to quickly take a few minutes, look at this question, tell me what do you think your N is and what do you think your I is. Right, so you can pause this video and see if you can come up with the N and the I correctly. Now, I would like to assume that you did what I asked you to do, which is to pause the video and figure out your N on your own. Now, let's do it together. Now, it is 3 monthly. It means in 1 year, there are 4 compounds. So, in 3 years, there will be 12 compounds, which is 4 times 3. And my I, if you are not setting your machine like me, then you are going to divide your 10 divided by 4. But if you set a machine, you don't divide by 4. The same, let's go to the answer. So the answer is 1000, right, plus minus, that is your PV, and then your 12 is your N, and then 10 divided by 4 is your I, then compute FV. For the last time, I will show you how to use both calculators, then from now onwards, I believe you will be knowing. Right, so remember, we said 1000 plus minus PV, we said 12 is our N, and 10 divided by 4 is our I, then we compute FV. Now, same thing here, 1000, remember, clear the memory. Alpha 00, 1000 plus minus is your PV, then your 12 is your N, and 10 divided by 4 is your I, and then you compute FV. As you can see, the answers are just the same, 13448888. Right, so our answer is 1344.89. Right, so quickly, let's go to the next one. It's compounded 4 monthly. It means in 1 year, there are 3 compounds, 4, 8, 12. Now, let us calculate our N. So your N is, of course, 3 per year times 3 years, which gives you 9. And your I is 10 divided by 3. And let's just finish this one. Is 6 monthly, so it's 2 per year for 3 years, so it's 6, and it's 10 divided by 2 because it's compounded monthly. So there we go. So let's go 1000 plus minus PV, then 9 is your N. Okay, I think I did not clear my memory. Just do it again. 1000 plus minus, that's PV, then 9 is your N, then 10 divided by 3 is your I, then you compute future value and you get 1343.27. Right, and then let's go to the last one. Then that's again, clear my memory, then it's 1000 plus minus, that's my PV, my 6 is my N, and 10 divided by 12, sorry, 10 divided by 2, okay, 10 divided by, okay, sorry for that mistake, 1000 plus minus PV, 6 is your N, and 10 divided by 2 is your I. Right, then we compute our FV, which is 1340.10. There you go. So I've given you the answers from A to E, and I think you can now see now the differences, especially with respect to N. So N, please spend much time on N and be familiar with how to calculate N. Now let's quickly move on to the second part, which is computing an effective rate. Computing an effective rate. So let's say you see let's say you see a poster, right, that says, come to our bank ADSA, right? Come to our bank ADSA. We are offering 10% per annum compounded 2 monthly. Compounded 2 monthly. Okay. So you see this advert and you decide, okay, I'm going to invest my money. So you go to the bank and then you invest 1,000 rand. Okay. So let's see. How much would you expect? So obviously, if you don't know this thing of nominal and effective rate, you would think that your interest is 100 rands, which is simply 10% times 1,000. So of course, if you don't know, then if I'm working there at ADSA, I'll probably steal a few cents from you, and I'll give you 1,000 and take the rest. So we need to know that this rate that is here, the one that is in the newspaper, this is called the advertised rate, which is also referred to as the nominal rate. So the advertised rate is the same as the nominal rate. Now, let's look at what exactly are you earning. You see, you are not actually earning the 10% per annum. No. You're actually earning more than that. We did this question just now. So there's no need to waste time. Or anyway, that one was for 3 years. My apology. So we might have to do this again from scratch. So let's see, how much are you going to receive at the end of the year? So FV at end of year 1. At end of year 1. So it will be 1,000 plus minus PV. I think by now you all know how to get your N. Now remember, it's only for 1 year and it's compounded 2 monthly, so your N is 6. Now your I, it will be 10 divided by 6, right? And then okay, and then you compute your future value. So quickly, let's do that. So it's 1,000 plus minus PV, then 6 is your N, then 10 divided by 6 is your I. Compute FV. So you see, you now get 1,104.26. Now let's see, what exactly are you earning, right? What exactly did you earn? So 1,104.26 minus 1,000 gives you 104.26 rands. So this is the interest earned, right? Now quickly, let's now calculate the interest rate. Obviously, it will be 104.26 divided by the money that you invested multiplied by 100%. So we want to see your rate of your interest rate. So 104.26 divided by 1,000 times 100% gives you 10.426. You see, 10.426% per annum. So this, the actual rate now that you are earning, this one is called the effective rate, or the actual rate earned, the actual rate that you have earned. So remember, there is the advertised and the actual. Sometimes they might be different. Nominal, effective. Advertised, actual. So you see, you need to know. You need to know which bank, or should I say which, let's say you are given 2 or more banks with a different advertised rates. You must know how to compare them. And how do we do that? We calculate the effective rate. Now let's see, how do we do this? Now remember, when we say rates are equivalent, we mean they're equal, right? Now if they're equal, it means if I invest 1,000 and you invest 1,000, right, the future values must be the same. So let's look at our formula. S is equals to 1 plus I over m to the power of m times n, right? So for now, let's just say we want to consider for 1 year, right? So let's say this is ADSA, and we also have another bank which is 1 plus I over m to the power of m times n, and then this is, let's say, Fed Bank, or let's say Feb Bank. Okay, so we've got Feb Bank, we've got ADSA. So now if let's say this is 1, if they are using 2 equivalent rates, so let's say they are saying I per annum compounded monthly, I per annum compounded 2 monthly, or no, one of them must be annually. Sorry, let me make this to be annually. I'm not yet there on the 2 monthly. Annually, there you go. So we know that an effective rate, right? Remember, an effective rate, it is also a rate that is compounded only once a year. Compounded only once a year. So an effective rate is a rate that is compounded once a year, or an effective rate. Okay, let's not say it's a rate. Let's say an effective rate is compounded only once a year. Okay, so let's look at this scenario here. So if these 2 rates are equivalent, it means they will give us the same answer. So if it means the S will be the same as that, so let's cancel all the stuff. And I left my A here, I also left my A there. But since they are the same also, let's also cancel that. Let's cancel that as well. And we are going to invest our money for 1 year. So let's cancel the 1 year because it's the same as the 1 year. Now, you see, we're left with this. So what this means now is 1 plus, right, I over, let's say 12, because it's obviously compounded monthly, to the power of 12 should be equal to 1 plus I. Now, how is this possible? Right? It's simply because this M, remember we said an effective rate is compounded once a year, so the M will be 1. Also the M will be 1. Now remember, when the power of a bracket is 1, we can easily ignore the bracket. So it means the bracket will fall away, and also this I over 1 is same as I. So this is a formula for an effective calculating an effective rate. So some books, they normally change this one to J, right? It's just the same thing, right? There is really no big difference. So like the way it's written in our notes, it is 1 plus I is equals to, open bracket, 1 plus J over M to the power of M. So of course you know that, as you can see, this is exactly the same as that, and of course the opposite is true. So this is how you calculate an equivalent effective rate. So let's use that question again. which is 10% per annum compounded to monthly. So obviously this is your effective rate that we are looking for. Effective rate. So what do we do? The 1 obviously must go that side, and it will be a negative. So it means I is equals to, so we want to use that question there on top, 1 plus, so your J is now your 0.1 divided by your M. Remember M by now you should now know what M is. M is number of compounds in a year. So if it's 2 monthly, it means this is 6, right? And then you close, and of course it's also 6. But remember, we said the 1 must go there, so it's now minus 1. But remember, whatever answer you get here, it will be decimal. It must still be multiplied by 100%. So let's quickly do that. So let's go. You open bracket, 1 plus 0.1 divided by 6. You close your bracket. You raise it to the power of 6. You minus 1, and then you get your answer. You see. And remember, I said your answer will be a decimal, so you multiplied by 100, and that gives you so this is 0.10426, which is the same as 10.426% per annum. Now again, if you are using HP, same thing. I remember giving you the same calculation. So we first open this bracket here, right? So we go shift, open bracket, 1 not 1. So we've opened our bracket. You go 0.1 divided by 6, which is that one, then plus 1, which is that one, then you close your bracket, then you get your answer, then you raise it to the power of 6, right? Then you get your answer, and of course you minus 1. There you go, same answer, obviously multiplied by 100, and then 10.426. So this is how you get an effective rate given a nominal rate. Now let us compute using a calculator. There's also a way that you can get the same answer using a calculator. Now quickly, let's see here. Let's see. So we are given 10% per annum compounded to monthly. We want to convert this to an effective rate. Right, so there you go. So now I'll start with the sharp first. Right, so you press 6. Why 6? Because the rate that you want to change is compounded to monthly. So there are 6 compounds in a year. 6 compounds. And then you press the XY. There's the XY button. XY. So you press XY there. Then you press your rate, which is 10, and you press 10. Then you go second function, EFF. Now let's look for EFF. There it is on PV. Right, so we now say second function, EFF. And there you go. 10.4260. 426. There. Now for the last time, 6. Why 6? Because there are 6 compounds, XY, right? And then 10, then second function, EFF. Get your answer. Now I'm going to show you now with the calculator. Now, with this now, you have to set now. This is the only time you are forced to set. So you set your calculator, which is, because it's 2 monthly, so it's 6 per year. So you go 6 shift per year, right? So we've set our machine to 6 per year. Then 10 is your nominal rate, right? And you say second function, EFF. So there is your EFF there, EFF. Still, you see, same answer. So again, for the last time, you go, if you're using HP, so this is for HP, you say 6, then shift. Of course, remember it is the downshift, right? Shift, then PM, sorry, per year. So we now set a machine to 6 per year. Then you say 10, and that's your I. Then finally you say shift, it's a down arrow. Say shift EFF, which is your PV button, and then you get your same answer. So that's how you get an effective rate using a calculator, effective rate using the formula, right? And in this case, we were changing 10% per annum compounded 2 monthly to an effective rate, right? Compounded 2 monthly, and so there we go. So this is how we change a nominal or an advertised rate to an effective or an actual rate. Right. What if I want to change from one nominal to another nominal? One nominal to another nominal. So let's say now this is conversion from one nominal to another nominal to another nominal to another nominal. So from one nominal to another nominal. There you go. So let's say you are given 10% per annum compounded, 10% per annum compounded, let's say monthly, and then they ask you to find an equivalent rate, find an equivalent rate, but now compounded quarterly. Find an equivalent rate compounded quarterly. So we want to change 10% per annum compounded monthly. Find an equivalent rate compounded quarterly. Now the formula that we use is, remember, like I explained here, I'm not going to explain again what I was explaining here. Right, so it is the same. I'm going straight to the formula, which is 1 plus J n over m, over n to the power of n is equals to 1 plus Jm over m to the power of m. Now don't be confused. This n is no longer the same n as the one you know. It's just there to differentiate between these two. Otherwise, someone could have used m1 and m2, right? m1 and m2, which is just the same. So don't be confused by this n. It is still the same as the m that you know, but for now we're just using it to differentiate the two, right? So on the left side, you write what you are given. My apology. You write what you are looking for. On the left side, you write what you are looking for is equals to, then on the right side, you write what you are given. So left side, what you are looking for, right side given. So what are we looking for? We are looking for a rate that is compounded quarterly. So it will be 1 plus j over, if it's quarterly, obviously it will be 4 quarters per year to the power of 4 is equals to, then that's 1 plus, now you write what we are given, which is 0.1 divided by 12, but it's compounded monthly to the power of 12. Now I'm going to show you this. So firstly here, I'm going to continue with that there. We need to make j the subject of the formula, but how do we do that? So we are going to make the power to be 1, because if the power is 1, then we can easily get rid of the bracket. So how do you make the power to be 1? You divide by 4. But remember, just like with identical twins, you buy a blue short there, you also buy a blue short that side. Otherwise, those two will fight. So if you divide by 4 there, you also divide by 4 there. So if I divide by 4 here and divide by 4 there, my answer is now 1 plus j over 4 is equals to 1 plus 0.1 over 12 to the power of 3. So as you can see, 12 divided by 4 is equal to 3. Okay, so let's continue. The 1 must now go that side, right? So it's now j over 4 is equals to 1 plus 0.1 over 12 to the power of 3 minus 1, right? So again, if you want, you can now start solving it here, or you can wait for a while. If you want, you can solve it here and get your answer and continue, or if you want, just wait up until we are left with j this side. So what do we do here? We must now be left with only j. So how do we do that? Obviously, we multiply both sides by 4. Multiply both sides by 4. So your answer is going to be, because the 4 will cancel with the 4, and you're left with j is equals to 4, right, times 1 plus 0.1 over 12 to the power of 3 minus 1, close the second bracket, then you get your answer. But as usual, your answer will be a decimal. For you to make it a percent, multiply by 100. I think by now you know that. So again, you punch it as it is in the calculator. So you open 2 brackets, then you first of all press 4, you open 2 brackets, then you go 1 plus 0.1 divided by 12, then you close the bracket and you raise it to the power of 3, right, and you minus 1 and you close the second bracket. So as it is, then you get your answer as 0.1, but of course multiplied by 100, and then that gives you 10.08. So 10.084%, of course, per annum, but now remember, compounded quarterly. So what we are saying is 10% per annum compounded monthly is equivalent. So this is equivalent to that. These two are the same. So if a bank gives you 10.084 per annum compounded quarterly, and one bank gives your friend this compounded monthly, really you are the same. There's no difference there, right? So now let's quickly look at how do we use the HP calculator to do that. So I prefer to start with this always, right? So I'm going to open my bracket for this one. Then I start with that, which is 0.1 divided by 12, right? Then I add my 1, then I close my bracket, I raise it to the power of 3, I raise it to the power of 3, I get my answer, I minus 1, which is this one here, I minus 1, I get my answer. So this answer is the answer for this bracket, for this 4-corner bracket here. And of course, lastly, I multiply by 4, and I get 0.108. But of course, if you want to make it a percent, you must multiply it by 100%, which again gives you the same answer. So this is how you use the formula to calculate an equivalent rate. Now, there's also a way that you can use to get the same answer but using a calculator. So we are going to do that again. So we want to convert 10% per annum compounded monthly. So we want to convert that to an interest, to an equivalent nominal rate, but that is compounded quarterly. Okay, so what do we do? So firstly, you have to enter what you are given, right? So you are going to say, as usual, 12 was this, yes, it was monthly, sorry, it was monthly. So you now say 12, right? And then as usual, XY, just like before. So 12, this is for the sharp. 12, then you say XY, and then you put your, I think by now you all know why 12 first, because it's 12 compounds if it's compounded monthly, 12 compounds per year. And then XY, then 10, and you know what to do, second function, EFF. And so there you go, 10, second function, EFF. Now you can copy that answer down, but normally, yeah, you can just copy it down there, which is 10.47 for the sake of the person who is marking 471, right? But here I'm going to store my answer. So I'm going to press store, then amount, or you can store in B or store in C or D or E or F. I mean, you choose even Z, Y, X, right? So normally I use amount or A. So I store in A to avoid to punch it again, right? Okay, so now I've calculated my effective rate. Now I'm now going to calculate now my compound, my rate that is compounded quarterly. So I'm going to say 4. Why 4? Again, is because it is 4 compounds, right? Then XY is usual. So 4XY. Now, if you did not store your answer, you might have to now put it manually now, like 10 point something. But for me, I did store it. So I'm going to say recall, then where I stored my answer. You see, my answer now will appear again. And I will have all my decimals. So my answer obviously will be correct. So if you are to copy it down, please make sure that you copy at least 5 or 6 decimals. So once I do this, then I say now second function, APR, or the nominal. So that's 10.471 then second function, APR, and the answer is 10.08. 10.08. Okay, just bear with me there. 10.08, which is exactly the same answer as that. You see, 10.084, 10.084, same answer. So again, for the last time, let's go through the steps. First of all, you say 12 because you are given a monthly rate. 12 XY, 10 second function EFF, you get your answer. Then you say 4. Don't clear the memory. Don't clear the memory, please. Don't clear the memory between these two steps. Then you say 4 XY, then 10 point, then second function APR or second function PMT. All right, and then you get your answer. Now I'm going to show you now using HP. So first of all, you need to set your calculator to 12 per year. Why? Because the rate that you want to change is compounded monthly. So you are going to say 12, right, shift per year, and then there it is 12 per year. Then our nominal rate is 10. Press 10 there. Then you say shift EFF. So you are going to say, if you are using, so this is for sharp. So this one is for sharp. Now let's use one for HP. So you are going to say first of all 12 shift, then PMT or per year, right? Then you are going to say 10, then that's your I. So you have entered this information for now. Then you now say shift, right, EFF or shift PV. Shift PV, okay. Then you get your answer, which is 10.471, the same as that answer there. Okay. Then you now say 4. Why 4 now? Because the rate that we're looking for now is compounded quarterly. So we are now going to reset our machine to 4 shift PMT. So it's now set at 2, but don't clear the memory. Please don't clear the memory. Just say 4 shift PMT. Don't clear them. Now you now say 4 shift then PMT to set the machine to 4 periods. Then remember that effective rate, it is still stored there. So you now say shift nominal. So you are saying to the machine, give me a nominal rate that is compounded quarterly that is equivalent to that effective rate. And as you can see, so this is shift nominal, which is equals to, there is our answer, 10.0834. 10.08, okay, let me just say 84. There you go. And for those who have got, sometimes your calculator might have only 1 decimal or 2. If you want to change it for sharp, you simply say shift, then you press this equal sign, and then you press 5. You see now you've got 5 decimals. Again, shift, the equal sign, then 9. It goes back to 9 decimals. If you are using HP, I advise you leave your machine at float A or float B or tab 9. So you can do setup 03. So it's now at float B. Or you can say setup 0. Now you can say 0 for tab, but now choose 9 for 9 decimals. So it's now at tab 9. But normally I use float A or float B. Right, there you go. Okay, so this is how you compute an equivalent rate, an equivalent nominal rate from one nominal to another nominal. That's how you do that. And the last part that I would like to explain as far as compound interest is concerned is when we've got deposits and withdrawals from the same account. So now that I've introduced compound interest, you now know what it is. Now let's quickly look at this. There's a question that I used before. Let me see if I can get that. There it is. So you see we've got our timeline, and from our timeline, as you can see, okay, for now I want you to ignore these figures that you see over there, Let's look at the timeline. It starts from 0, it goes all the way to 17. So the question on this page was find the unknown. Now the unknown in this case, it is the balance. So these are deposits and these are withdrawals. As you can see, your withdrawals, they are your withdrawals are in brackets. So now for now, I'm not going to use payments as this. I'm going to draw another timeline and just give you a once-off amount, right? So let's do this. I'm going to come back to this question, but for now, I'm going to give another timeline. I just wanted to show you what I am talking about, whereby we've got deposits and we also have got withdrawals from the same account. So I'm going to draw another timeline here. So that's 0, that's 1, that's 2, that's 3, that's 4. So at 0 here, you deposited 10,000. But at 1, you withdrew 1,000. And at 3, you also withdrew, let's say, another 1,000. Then they want to know what is the balance. Calculate the balance at the end of, let's say, what is it? Is this month or, okay, let's say they are months. So your timeline is in months. So it's 4 months, right? 0, 1, 2, 3, 4. End of month 1, month 2, month 3, and month 4. Okay, so quickly, let's look at this, and let's say the interest is 10% per annum compounded monthly. Right, so the question is calculate the balance here. Calculate the balance at month 4. Okay, so what do we do? Whenever we've got deposits and withdrawals or the same timeline or from the same account, what do? You push them all to one date, and that date is what we call the focal date. So this date here, that is at the end of month 4, is called our focal date. In simple terms, we are focusing on that period. So everything must be brought to 4. Everything to 4. Let's start with our deposit. So calculate future value of deposit where? At the end of month 4. If you have got 2 deposits, again, do the same thing. Do them one by one, but push them all to month 4. So here it is 10,000. Right, it is 10,000 plus minus PV. Your N, I think by now you all know, compounded monthly, 4 months, so your N is 4. And your I is 10 divided by 12. 10 divided by 12. There you go. Now, let us compute our FV. Right, so you can use your HP if you're using HP. I think by now you know how to do the calculation. So 10,000 plus minus PV, and your 4 is your N, and 10 divided by 12 is your I. And then you compute FV. So this gives you 10,337.52. So it means this amount at the end of month 4, it is worth, or it is 10,337. There it is. Now the second step now is to calculate the future value of withdrawals. Future value of withdrawals. Future value of withdrawals. Future value of withdrawals. When? At the end of month 4. Now since there are 2, where we are going to do one at a time, so it's either you can use the calculator or you can use the formula. So you can say 1,000, right, into 1 plus 0,1 divided by 12 to the power of, now remember from month 1 to 4 is 3, then plus 1,000 open bracket 1 plus 0,1 divided by 12 to the power of, so it's only 1, which is, yeah, So just leave it like that. So this one is for that one, and the second one is for that one. So you can use this, or you can use the calculator. So you can do FV for this using the calculator, again AV for this, also use the calculator, and add the two AVs, same thing. So I'm going to use this one, the formula. Remember, I want you to be familiar with both calculator and formula. So 1000, punch it as it is, 1000, open bracket, 1 plus 0.1 divided by 12, close bracket, raise it to the power of 3, right, plus 1000, open bracket, 1 plus 0.1 divided by 12, close bracket, raise it to the power of 1. Anyway, there's no need to erase it because it's just 1. So nothing will actually change. So there we go. What do we get? We get 2033.54. 2033.54. Now, the balance now. So since this is a future value of deposits, a future value of withdrawals, future value of deposits, so balance is the difference. Balance is equals to 10,337.52 minus 2033.54, and that is it. And now you'll get your answer. Now, before I go to the next part, I think I need to explain something with regards to interest rate. So I'm going to say here input. I'm going to say here output. And remember, this is only applicable to those who do not set their calculators. If you set your calculator, this is not applicable to you. So I just want to make something clear here about your interest rate. And for all questions, we are going to use 10%. Right? So we are going to use 10% per annum. Right? But on A, it is going to be compounded monthly. Now B, again compounded 2 monthly. C, compounded 3 monthly or quarterly. Compounded 4 monthly, and compounded half yearly, and finally compounded yearly. So remember, like I said, it's for those who don't set their calculator. So what do I mean by input? I mean when you are given your I. Now, what do I mean by output? When you are looking for I. Now, when you want to put in your I, and your I is 10% per annum, compounded monthly, you are going to say 10 divided by 12. If it's compounded 2 monthly, you say 10 divided by 6. 3 monthly, 10 divided by 4. 4 monthly, 10 divided by 3. Half yearly, 10 divided by 2. Yearly, you just say 10 because it's divided by 1. Now, remember, what you put in the computer is what you get out. Now, can you imagine what if we were computing I? The machine will give you the same answer here, which is 6. So when you are to say, let's say you say compute I, then the machine will give you 6. Why? Because your calculator is not set. It's set at 1 per year. So if you're dealing with months, whatever answer you get here, is a monthly rate. If you are, remember, once again, if you are, this is only applicable to those who do not set their calculators. Okay. So, if you are looking for I, that means you must multiply. Whatever answer you get, you multiply it by 12. Whatever answer you get, you multiply it by 6. Whatever answer you get, you multiply it by 4. Whatever answer you get, you multiply it by 3. Whatever answer you get, multiply it by 2. Here, there's no need. You just take it as it is. Right? So, it's okay. Your answer is final as is. It will give you 10. So, obviously, when you compute I here, the calculator will give you, let's see, 10 divided by 12 is what? The calculator will give you 0.833 what. If you multiply that by 12, then it gives you 10%. Again here, if you compute I, the calculator will give you 10 divided by 6. It will give you 1.666 7. If you multiply by 6, again you get 10. And same thing applies to the other ones. So I want you to remember this. For those who are not setting their calculators, right, this is how you input your rate. This is how you output rate. If you are looking for a rate, if you are given a rate, looking for a rate, right? Let's quickly look at an example that illustrates what I'm talking about, and also other things of compound interest. Let's look at this question here, which you do not have, and I cannot copy it down here, but I'm going to read it from the book, and then let's see if you can see that one. I think you can see it. Yes. So let's go. An amount of 25,000. So an amount of 25,000 is invested at a certain annual rate of interest, compounded monthly, right? So an amount of 25,000 is invested at a certain annual rate of interest, compounded monthly. So we don't know the rate. Study the information relating to the first 2 months and answer the questions that follow. Right? Okay. So the principal is what? Is 25,000. Now we are given interest for 2 months, month 1 and month 2. So the question says compute the effective rate. Okay. So let's come here. What do we know about an effective rate? An effective rate is a rate that is compounded only once a year. Right? Okay. So if I come back here to my question, what's my PV? My PV is 25,000. Right? There it is, 25,000. So 25,000 plus minus PV. What is my FV? Is 25,313,48. 25,313,48. That's your FV, right? Then what is your N? Now this is where the problem is now. Remember, if you are looking for an effective rate, it's compounded only once a year. Now, you ask yourself, how many months are there, or what is the period between my PV and my FV? It's only 2 months. Because remember, they say study the information relating to the first 2 months. After all, you are given interest for month 1, interest for month 2. So your period is 2 months, but you know that an effective rate is a rate that is compounded once a year. So quickly, how many years are there in 2 months? Of course, it's not even more. It's not even a year, not even half a year. But see, the important part is, how do you convert months to years? That's the important part. Let me give you an example. What if it was 36 months? What if it was 36 months? How many years are there here? Obviously, we divide by 12. You see? So it is this concept that is very important. So now again here, you simply say 2 divided by 12. Because remember, we want to convert months to years. So 25,000 plus minus PV, and 25,313.48 is your FV, and then 2 divided by 12 is your N, and you compute I. You see, your answer is exactly as is, 7.76. No need to multiply by anything. Why? Because it's compounded once a year. That's why you see, that's why I gave you this table first. There we all go. We are looking for a yearly rate, so you don't multiply by anything. Output, you don't multiply by anything. So the answer you get there becomes your final answer. So your I is 7.7633. Done. So this is your effective rate. Now let's go to 2. Calculate the interest earned by the investment at the end of month 16. Now for this one now, you need to know this. We first of all need to compute the nominal rate. Remember, we are not given the nominal rate. We must know this rate. So that's the first step. 25,000 plus minus PV. Then your FV is still the same, 25,313.48. Now your N is going to change now. Remember, a nominal rate can be compounded monthly, 2 monthly, whatever. It is the advertised rate. So in our case, our nominal rate is compounded monthly. Now tell me, how many months are there between our PV and our FV? Is 2 months, right? Good. 2 months, just like here, 2 months. But our rate is compounded monthly. So how many compounds are there in 2 months if we are compounding monthly? So of course the answer is 2, because it's 2 months, right? And you compound monthly, so there are 2 compounds. So your N is 2. So remember, if you still remember the notes I gave you earlier about N, what did I say? I said the N is the number of compounds. So the N is 2. Now let's compute here our I. Compute I. So let's go. Remember, clear memory, 25,000 plus minus PV, 25,313.48, right, is your FV. Now your N is 2, then compute I. This is exactly what I was talking about. You see, this is your monthly rate. So to make it annual, you multiply by 12, and you get 7.5%. There you go. So this is a nominal rate. But remember, we are not looking for the nominal rate. We need to continue. They want you to calculate interest earned by the investment at the end of month 16. Now, if you still remember when I introduced compound interest, we said at the end of each month or at the end of each period, it depends with your intervals. Sometimes compound interest can be compounded monthly, sometimes it can be compounded yearly, sometimes it can be compounded weekly. It all depends. But if you look at that page that I just showed you about compound interest, you see that at the end of each month or at the end of each interval, we are going to calculate our interest based on the opening balance of that interval. So what I'm saying is, if let's say your interest was monthly, right, your interest is compounded monthly. What it simply means is, if interest is compounded monthly, at the end of the month, we are going to ask ourselves, what was the balance at the beginning of the month? Then once you have that balance, that becomes your A, right? And once you have that A, you now multiply by your I, which is your interest rate always given. Once you have your I, then There you go. That's what I'm talking about. So remember, when you're at the end of month 1, to get the interest of month 1, you need the opening balance for month 1, which is the opening balance is here. Let's go to month 2. To know the interest for month 2, you need the opening balance for month 2. Remember, opening balance for month 2 is the closing balance for month 1. That's why I put an arrow there. You see, so the closing balance for month 1 is the opening for month 2. So for you to know the interest here, you must know the balance first. So let's come back to our question. They want interest at the end of month 16, but our interest is compounded monthly. So we know that to get interest at 16, we must know the opening balance that is there at 15. So first of all, we need to know how much will be in the account at the end of month 15. So again, if it was compounded 2 monthly, we go 2 months back to 14. 3 monthly, you go 3 months back to 13. It all depends. But in our case, it is monthly. So we go 1 month back to 15. So we need the closing balance for month 15, which becomes the opening balance for month 16. So firstly, find FV at the end of month 15. So you say 25,000 plus minus PV, your N. Now remember, compounded monthly for 15 months, so obviously there are 15 compounds. And your I, you don't use the effective rate, you use the nominal rate, which is 7.5 divided by 12. Why? Because it is compounded monthly. Right? Okay. So let's go. 25,000 plus minus PV. 15 is your N. And 7.5 divided by 12 is your I. Then you compute your FV. So your future value is 27,449.12. Now once you get this now, you can now use interest is equals to AIN to get the interest at the end of month 16. Okay, so let's go. 27,449.12 times 0.075, which is your nominal rate, but of course as a decimal, right, multiplied by 1 over 12. Why 1? Because it's only for 1 month. Remember, this is an annual rate. It is for 1 month. So again, let's punch it. Times 0.075 multiplied by 1 divided by 12, and you get 171.56. 171.56. 17. So 449.12 times 0.075 times 1 divided by 12. Okay, I think sorry, my answer I think is wrong. 449.12 multiplied by 0.075 multiplied by 1 divided by 12. Yes, sorry, the answer is actually 77.81. My apology for that. 77.81. Right, 77.81. Okay, I think I'm a bit confused here because I'm using the wrong figure. So actually my answer is 27 here, not 12,000. So it is 27,449.12 multiplied by 0.075 multiplied by 1 over 12, and this gives me my first answer, which is 171. So 27,449.12 times 0.075 times 1 divided by 12, and yes, so that was correct. 171.56. 171.56. 171.56. My apology for this confusion. I mixed up my numbers. So your interest is 171.56. But what I want you to check here is, how did we get our N here? Remember, number of years. What about here? Check number of compounds, or same as number of years. Why? Because the interest is compounded annually. Number of compounds is for 2 months, interest compounded monthly. Then there you get your answer. So this concludes compound interest. Please do more questions and more questions to see if you have understood the concept very well. Okay, so now I'm going to introduce annuities. Right, I'm going to introduce annuities, and although there are many types of annuities, but I'm only going to introduce 2 types. The first one is an ordinary annuity. An ordinary annuity. And the other one is an annuity due. An annuity due. So I'm going to draw 2 timelines. Then 0 there. And let me say 1, 2, 3, 4, and 5. And then again I draw another one down there. And it's 0, it's 1, it's 2, it's 3, it's 4, it's 5. Now, an ordinary annuity normally is when payments are made at the end of each interval. At the end of each interval. And again, normally annuity due is at the beginning of each interval. So e.g., if you're paying money monthly, you pay at the beginning of each month, normally that's an annuity due. But there's a tricky part to that now, which I'm going to explain just now. So let's say here we've got PMT, we've got PMT, we've got PMT, PMT, and PMT. Now, that's the new guy in town that you must also hook up with, PMT. Spend some time with this guy and then get to know him better. Also PMT there, PMT there, PMT there, and PMT and PMT. Now, fine. This is, from what I've said there, this is an annuity due, right? But it's not conclusive. In many cases, it's not conclusive. What I want you to look at is, I want you to look at the position of your present value and your first payment, right? So rule number 1, fine, over and above what I've said here, I'm going to give you now things that will guide you not to go wrong. Now, your present value and your first payment, if they are on the same date, this is an annuity due, right? And if the present value and first payment, if they are one interval, now take note, it's not 2, not 3, it's one interval. It's either 2 months or month, it depends. If these are monthly, this must be a month. If it's yearly, this must be a year. But remember, there must be one interval. So this is an ordinary annuity. Ordinary annuity, right? Now, let's look at the future values. So FV and FV. Again, if your future value and last payment are one interval apart, again, same thing, annuity due. Also, if your FV and your last payment are on the same date, it's an ordinary annuity. So this timeline is for an annuity due, and this timeline is for an ordinary annuity. So what does it mean when it's an annuity due or an ordinary annuity? Now I want you to look at your calculator. Look at this button here. Yeah, is it an BEG/end? BEG is for beginning. So if you know that, okay, you are dealing with an annuity due, what do? So you are going to say shift, right, then BEG. So you see, if you say shift BEG on the calculator, you see that BEG there. If you want to remove it, same way you put it, shift BEG, and it's off, right? And the same goes for the Sharp calculator. Those guys who are using Sharp, look for your BGN button. There it is. See BGN/N. So if you want to put BGN, you just say second function BGN, right? So second function BGN. You see there it appears there. Second function BGN. Then there it's off. So that's what you do if you know which annuity you are dealing with, either BGN or an annuity due, right? And remember also one more thing to assist you. Remember, in compound interest we said N is the number of payments, number of compounds, which still applies to annuities, number of compounds. But now I want to add again another simplified version, which is number of payments. So if there are 10 payments, you know that is 10 compounds. If there are 20 payments, you know that is 20. If there are 10 payments, your N is 10. If there are 20 payments, again your N is 20. So that's the big N there. So this one, we already know it from compound interest. So you must now be familiar with that one now, number of payments. So this is annuities. And one more thing that you need to remember, the reason why we did the previous part of converting from one nominal to another nominal is because when payments are compounded monthly, when payments are made monthly, not compounded, when they are made monthly, interest must also be compounded monthly. So what are we saying now? If you are given a question whereby the interest is compounded monthly but the payments are quarterly, so you must change that monthly rate to a quarterly rate. That's why we did that part of converting from one nominal to another, right? So there you go there. When payments are made monthly, interest must, not may, must also be compounded monthly. Some people, they say these two are married. They must marry each other, like, share the same surname or whatever you want to call it, but these two, they must be related. Payments monthly, interest compounded monthly, right? So as far as annuities are concerned, this is everything, right? Once you master this, you will see that doing questions, it will be easy. Now let's look at a question. Let's look at question number, let's look at page 30 in our business calculations notes, and see the okay, there's a question there. I'm not going to copy it here. I'm going to read it to you. If you don't have the manual with you, you can just listen. I'll try to read it 3 or 4 times. Okay, so I'll read and write the variables here. So a person wishes to have 30,000 in a fund at the end of year 9. Now, what's important is a timeline. So there you go. So that's 0, that's 9. So this is 9 years. Okay? So this is 9 years. Okay? So a person wishes to have 30,000 in a fund at the end of year 9. Again, before I continue, the same elements that we did in compound interest, you must still remember them. PV, FV, but now there's a new guy now in town, and the new guy is PMT, then N and I. By now, I think you now know what is PV, FV, N and I. So the only new guy is PMT. Please spend time with these guys. If it means a day or two, don't answer any question. Just go through this, master them, know the their attire, what they wear, the tone of their voice, what they like to eat. Know them in and out. Then you'll be okay. Now let's come back to our question now. A person wishes to have 30,000 in a fund at the end of year 9. So of course, wishes to have, it means that one is your future value. Where? At the end of year 9. So that's 30,000. There you go. Now, the fund earns interest at 14% per annum, compounded annually. So this is 14% per annum, compounded annually. Okay, so 14% per annum, compounded annually. Okay, now number 1 says calculate the annual deposits the person must make to enable him to reach his target. So it's saying calculate the annual deposits. Okay, so of course you know, okay, I will just put 1 there, put 2 there, and yeah. So there's a deposit there, there's a deposit there, and of course deposit there. Right. So what do? We say 30,000 plus minus, that is your FV, because it's in the future. Because remember, we are here. 0 means now. So your N, remember I said your N is number of payments. So how many payments are there? There are 9 payments. And your I is 14. No need to divide by anything because it's compounded annually. What are we looking for? PMT. So you get a PMT as 1,865.05. That's number 1. Now number 2 says the interest rate drops to 10% from the first of the 5th year. Now let's stop there. Where is the first of the 5th year there? Remember I said 3, 4. Remember I said end of year 4 is beginning of year 5. So the first of the 5th year is just here. So it means after making 1, 2, 3, 4, right? After making 4 deposits, the interest rate changed. Now whenever there's a change, you must ask yourself, what was the balance just before the change? Okay, so let's calculate the future value of deposits when at the end of year 4. So it's 1,865.05. We now know that this is what the person pays per year because of that, right? Plus minus PMT. Then your N is 4, of course, because that is 4 payments. Then your I is still 14. Then if you get your FV, it must be 9,178.18. There you go. But this answer now is where? This answer now is here. 9,178.18. So the easy way now is, although there is another way also that you can do this. It now depends now. Because you see, the issue is when you write your exams, most of the times they'll give you steps, guidelines. If it was a blank space it will be easy, because now that we have this, right, there is a short way that you can get your answer straight away, which is I'm just going to explain that because you might use it later. So it will be 9,178 plus minus, that's your PV, right? And then your FV is still how much? Your FV is still 30,000, because that's what we need, right? And your N, how many payments are we left with? We've paid 4 so far. We must pay 5 more, which is 5, 6, 7, 8, and 9. So that is 5. Then your I is now changed to 10%. Then you compute PMT. You have not yet done something like this, but it's very possible. Although you might not be able to use it because you'll be given steps that you must do things the other way. So quickly, let's just verify our answer. 9178, right, plus minus, that's your PV, then 30,000, that is your FV, then 5 is your N, and 10 is your I, then compute PMT, right? And what do you get for your PMT? You get 2,492.79, 2,492.9. But now let's come back here now. Normally they will ask you to find the future value of this amount at the end of year 9. So we now must push this to year 9. So this is 9178.18 open bracket 1 plus 0,1. Remember, the interest rate has changed, to the power of 5, which is 9 minus 4. Then this answer is going to be 14,781.55. So as you can see, if I'm to put 14,000 there, 781.55, it's not enough. There's a shortfall, and that shortfall is 15,218.45. But not to worry. Why? Because we are still going to continue. It is only the interest rate that has changed, but we are going to continue with payment 5, 6, 7, 8, and 9. So these payments now are the ones that are going to give us the balance, right? So let's do the last part. Allow me to just add one thing there. There we go. So let's now do the last part now, which is, so the shortfall is now equal to 15,218.45. Now this becomes your new FV now, 218.45 plus minus FV. Then your N is 5 payments, 1, 2, 3, 4, 5, and your I is 10. Let's compute what? PMT. So let's go. 15,218.45 plus minus FV. Your 5 is your N and 10 is your I. Then compute PMT. Same answer, 2,492.74. Of course, there will be just a minor difference of 5 cents, but it is immaterial. You see, 2,492.74, 2,492.79. But if the answer space was blank, you could do this. But the problem now is sometimes they will give you steps, like hints, like they will say compute the above amount till end of year 9. So obviously you must now do that approach. Get this answer first at year 4, push it to year 9, and get your shortfall and your PMT from there. So that is the question there on page 29, right? That That is our answer there on page 29b. Right. So let's look at another question. Let's see. Let's look at another question, which is on page 30. Let's go to page 30 of our handouts, the BC handouts, page 30. Right, so let's quickly look at page 30. If you do not have the manual, I'm going to read the question as usual, draw the timeline, and we can answer it. Now remember, we are currently busy with annuities, which I introduced just now. Let's go. So on page 30, the question reads, 200 was deposited into a savings account. So at this moment, you cannot tell if 200 is PMT or if it is PV, right? But you know that it's one of the two. So 200 was deposited into a savings account at the end of each month. Now you know, at the end of each month. So that is now PMT for 18 months. So if I were to draw a timeline, it will be something like this. So there will be 0 and there will be 18. Okay. So of course the first payment is at 1, which is how much? 200, and the last payment is at 18, which is also 200. Now the question says, how much will be in the account at the end of month 30? Now it means you need to extend your timeline now from 18 to 30. So there is month 30. How much will be in the account at the end of month 30? If interest rate dropped to 9% compounded monthly from the beginning of the 12th month. Now you see, now where is the beginning of the 12th month? Just like before, the beginning of the 12th month is the end of month number 11. So somewhere there, anyway, you put your 11. So this is the end of 11, beginning of 12. So right there, the interest rate dropped. So before this part here, from there up to there, your interest rate is 12%. Right, your interest rate is 12% per annum. But of course, you know that it's compounded monthly, right? Then from there now, going forward, is now 9%. And remember, interest is compounded monthly. Now remember what I said earlier on. When payments are monthly, interest is monthly. And here our payments are monthly, and our interests are also monthly. So there's no worry. There's no need to calculate an equivalent rate. But 11. So the beginning of the 12th month. 12th month starts here at the end of month 11. So this way the rate changed. Again, just like the previous question that I've done with you, whenever there's a change, you ask yourself, what was the balance just before the change? So first step is compute FV of deposits or of payments, whatever you want to call it, when at 11. So you go to 200 plus minus PMT, right? And then your N, how many payments are there? Of course, there are 11 payments. And then your I, it is 12 divided by 12 because it's compounded monthly. Remember, it's for those who don't set their calculator. And all the sharp users who don't set, HP user, you decide. But my suggestion is also don't set. Right? So we are going to compute here our future value. So quickly, I'm going to do that now. And your FV is 2313,37. That means here these payments there, they give me 2,313,37. Now what do we want now? Let's now take this answer, right? This answer here. Let's now take it forward. Where to? To 30. Because remember, the question says, what is the balance in the account at the end of month 30? So once you get the PV at 11, you now push it to 30. So it's once you are now at the end of month 11, this, although it was FV before, but now that I'm there at the end of month 11, it becomes my PV. So 2,313.37 into 1 plus 0,09 divided by, now it's 30 minus 11, which divided by 12, because it's compounded monthly. This is 30 minus 11, which is 19. Right, remember, 30 minus 11. So this is 30 minus 11. The 30 there minus the 11 there. Right. So if you compute this, you should get 2,666,25. 2,666,25. Now it means this answer is there, 2,666,25. Now let's look at the next payments. Remember, the interest rate changed here, but we did not stop with our payments. We continued up to 18. So again, let's compute again the future value of deposits when at the end of month 18. Now remember, you can choose. If you want, you can put your answer at the end of month 19. That means you are now dealing with a BGN. You are not using BGN because you are now dealing with an annuity due. But I would advise you that when you are given an option to choose, rather stick to an ordinary annuity. Right? So since payments are at the end, let's just use an ordinary annuity. So we're going to say again 200 plus minus PMT, nothing has changed. Now the N of course will change. Now you don't say 18 minus, remember the first payment here after the decrease in rate is payment at the end of month 12. Now you don't say 18 minus 12 because 12 is included. So you say 18 minus 11, which gives you 7. Right? And your I is now changed to 9 divided by 12. So remember, 12, 13, 14, 15, 16, 17, and 18. If you count them, 1, 2, 3, 4, 5, 6, and 7. So there are 7 payments, right? And then your FV is going to be equal to 1,431.90. But again, it's not here. The FV is not here. It's here at 18. So it's 1,431.9. Now again, you need to push this answer where you must push it forward to 30. Right? You must push it forward to 30, and the same way as we did before, right, which is 1,431.9 into 1 plus 0,09 divided by 12 to the power of, now the power, you simply say 30 minus 18. There's no need to go 1 month back. Why? Because there are no payments here. So you just say 30 minus 18, and that gives you 12. And your answer is 1,566.22. So it means in total 1,566.22. So in total, this is what you have at the end of month 30. So if you add these two, you get an amount of 4,232.47. There you go. So we have answered the first part that said how much will be in the account at the end of month 30. It's 4,232. Now the second part now says calculate the interest end. I'm going to squeeze it here. Now the interest end, remember I explained it just before, but you might have forgotten that. Remember I said interest end is equals to amount received right, minus amount invested. Amount received minus amount invested. So this gives you your interest end, or just interest. Okay, so having said that, now let's quickly see how much did we receive. So of course we received 4,232.47, but how much did we invest? Now our investment was not a once-off amount. We invested 200 rands, but for 18 months. So this is a total investment, and of course the difference is 632.47. So that is the interest end. So you see, it's very important for you to be able to draw a timeline. Now let's see if you can draw a timeline here on this question. Let's go to page 32. If you've got your manual with you, just go to page 32. If you don't have your manual, it's okay. I'm going to read the question, and please listen very carefully. Harry and Mary want to go on holiday in 24 months time. Okay, so immediately you know that whatever will be happening to these two, it will happen where? In 24 months time. Okay, the trip is estimated to cost them. Now you see, we are told that they want to go on holiday in 24 months time, and by then the trip is estimated to cost them 70,000. So of course you know that the 70,000 becomes your future value at 24, right? And then that is the info. Now let's go to number F. Harry makes an initial deposit of 20,000. Where? Initial deposit. We all know that it's here now, right? 20,000. Okay. Then what do the monthly deposits reduce to starting end of month 8? So the monthly deposits now are starting at the end of month 8, right? At the end of month 8. And remember, these are monthly deposits, so it's 8, 9. So you can put PMT there, put PMT there, and of course if they don't tell you where to end, you also assume that we will end at the end of month 24, right? To reach their target of, okay, let me read again. What do the monthly deposits reduce to starting end of month 8 to reach the target of 7,000 at the end of month 10? Sorry, at the end of month 24. Harry makes an initial deposit of 20,000, which is this one, into the account. What do the monthly deposits reduce to starting the end of month 8 to reach the target of 7,000 at the end of month 24? There we go. The interest rate that is given is 10.5% per annum, and it's compounded monthly. So there's no need for us to compute an equivalent rate. Right. So let's look at this. You see, if you can draw a timeline, then life is easy, because you just ask yourself, okay, if they deposit 20,000 towards a target of 70, how far will this take them as far as this is concerned? So the first question is, how much is it worth where at the end of month 24? So we say future value of deposit where at the end of month 24. So it will be 20,000 plus minus PV. Your N, of course, is 24 for 24 compounds. If it was compounded 2 monthly, your N will be 12. That's 24 divided by 2. If it's quarterly, your N will be 8. End. Okay, so your I is 10.5 divided by 12. So we're looking for FV. So quickly, let's do that. Or if you want, you can also use the formula, which is 20,000 open bracket 1 plus 0.105 divided by 12 to the power of 24. So you can choose. It's just the same answer. You get the same answer, right? So let's go 20,000 open bracket 1 plus 0.105 divided by 12 close bracket second function to the power of 24, and I get 24,651.03. Let's use a financial calculator. Okay, it's 4 per year, so I must change it to 1 per year as usual. Okay, there we go. So 20,000, that's plus minus PV, then 24 is your N, then 10.5 divided by 12 is your I, then compute FV. There you go, 24,651.03. That's so you can choose what you want to use. 24,651.03. Right, now that we know that this is 24,651.03, but you see, unfortunately, it's not equal to 70,000. So obviously, the deposit on its own is not enough, right? So we need to know what is the shortfall, right? And in this case, the shortfall now is 70,000 minus 24,651.63, which gives you 45,348.37. There you go. So that is the difference, right? And allow me to squeeze it right there. So we now need to raise this difference, but where is it going to come from? Oh, I see. That's why there are payments there. They are to raise that difference, that shortfall. So it will be now 45,348.37 plus minus FV. Your N. How many payments are there? 24 minus 7, or 24 minus 8 plus 1. Because if you say 24 minus 8, you have ignored payment number 8. So it's 24 minus 7, which is 14. 14. And your I is still 10.5 divided by 12. What are we looking for? We're looking for PMT. And remember, one thing also you must ask yourself is, what kind of annuity? You must also remember, what kind of annuity is this? Right? So the FV, which is this one, and the last payment are on the same date. Of course, it's an ordinary annuity, so we don't use BGN, right? So let's go then. 45,348.37 plus minus, that's your FV, then 14 is your N, and 10.5 divided by 12 is your I, then compute PMT. So it will be 3,058.95. Okay, let me just confirm that one. That's 45,348.37 plus minus PV, then 14, that's your N, then 10.5 divided by 12, that's your I, then compute PMT. Okay. 45348.37 plus minus FV, 14 is N, 10.5 divided by 12 is your I, then compute PMT. Okay, I'm getting a different answer there. Let's see here. 45 348.37 plus minus FV. 14 is your N, and 10.5 divided by 12 is your I, and compute PMT. Yes, it's 3058.95. Right. So basically that's annuities. So when you're doing annuities, the first thing to ask yourself is this an annuity due or an ordinary annuity? Right. So let's look at the question that I showed you before, the one I said I was going to come back to, and we see there is a question. Right. Remember I showed you this question before, whereby we've got deposits here of 1,000. We've got withdrawals there. But now let's see, deposits are monthly, because remember the timeline, we are told there on top that all timelines are in months, right? Okay, so let's come back here. So now it means this month 1, month 2, and they are deposits, and again here 2 there also, but now they want the balance. So if you still remember, I did a question before whereby there were deposits and withdrawals from the same timeline. And what did I say? I said we push them to one date, which is called the focal date. So in our case, it is 17. So let's start with the deposits. But now remember, there's no annuity whereby last payment is here and AV is there. It's either your AV will be here or it will be here. So you choose. If you put your AV here, it means you are dealing with an annuity due. If you put your AV there, it means you are dealing with an ordinary annuity. So I think you must know that. Okay, so for me here, I used this one. I used an ordinary annuity. So 1, 2, 3, 4, 5, 6, 7. That's your N. And 1,000 plus minus is your PMT. So 1,000 plus minus PMT, your 7 is your N, your I is 10% per annum compounded monthly, and you compute FV. So please do it and see if you get 7177.45. But now remember, we want to push it where? To 17. Hence it must now go further to 17. Now this becomes my present value, and my N becomes 17 minus 6. My I is still 10 per annum compounded monthly, and I compute FV. I must get 7,863.49. So this is the future value of deposits at the end of month 17. Now let's come to the withdrawals. Now there's a problem here. What's the problem? These are not monthly, they are 2 monthly. But our interest rate is compounded monthly. So immediately you see this, you must know that there's a problem. So we must calculate an equivalent rate compounded 2 monthly, and I did work it out, is 10,04 to obviously to the nearest 2 decimals. So I want you to also do it and see if you can get this. Remember, I've already explained to you how to get an equivalent rate. So use the calculator or the formula to get this answer. Now once you have it, now it means we can continue. One other thing, we want to find the future value of these payments were at 17. Now let's see, where is the last payment? Is it 15? Now from 15 to 17 there are only 2 months, and also the intervals between the payments is also 2 months. It means this gap here is equal to 1 interval. Now if you still remember your timelines, the ones I drew earlier on, remember I said when the last payment is there and FV is there, this is an annuity due, as long as this is 1 interval. Now since we've agreed that this is 1 interval, we might as well use BGN. So here there's no need to get your answer at 15 and then push it to 17. You can get your answer at 17 straight away. How do you do that? You simply put your 200 as a plus minus PMT, your 4 as your N, your I as 10.04 divided by 6. Remember it's 2 monthly, and you must put BGN. So you put BGN, then you say compute FV. Automatically your answer will be 817, 2 periods after the last payment, and your answer is 851.48. So this is the future value of withdrawals, future value of deposits. The difference, of course, is the balance. Remember, deposits minus withdrawal gives you the balance of 7,012.01. So basically, this is everything that you need to know for the June exam. So please go through your work again and see if there's anything that you don't understand. Go back to your notes, go back to the examples, come back again to this video, play it over and over again up until all the basics, you have mastered them. All the best.